Welcome back to the Algebra 2 series, and today we're looking at the prime factor method. This is video number 2, where we're trying to factor a trinomial that has some monstrous numbers. As you can see here, we have three numbers that are non-prime, but they're relatively prime, and so we'll have to try to work this out somehow. In the first video, I showed the technique for factoring these. The 24 gets factored and the 105 gets factored into prime factors. So this would be 2 times 2 times 2 times 3, or 4 times 6, which breaks that down. 105 is a little bit trickier. That one is 3 times 5 times 7, or in this case 35 times 3. So when we break these down into prime factors, in this example, we're trying to generate this 166, and we do this by a subtraction of factors because of that 105. Well, this is a very tricky problem because the 166 is an even number. So the only way I'm going to generate an even number is if I take an even number and subtract another even number. Now, I could also do it with odd minus odd, but that's not going to be possible because I have 2's as some of my factors. Right over here I have 2's, so I know I'm going to generate some even values. So I automatically see in this problem that there, I just trimmed off all my 2's there. Anyway, so I'm not going to see a way to do this with odd and odd. Therefore, I'm going to have to make two even groupings. And this gets to be a little bit tricky because when we have to separate our 2's into groupings, it makes for a lot more choices. But I'd like to just show a couple of tips on this one. First of all, let's take a look at this 5. The 5 is kind of important because when the 5 is paired with a 2, and we know that it will eventually be paired with a 2 because we have to break up our 2's. So there's going to be a 2 in the group with the 5. That's going to give us a 10, which means that one of our factors is going to be a multiple of 10 somewhere along the line. So I keep that in the back of my mind. And just for the sake of this example, we're just going to maybe group these this way with the 2 and the 5, and then all the rest of the terms go into a separate group. And I want to make these unbalanced because the number 166 here is such a large number. 2 times 5, therefore, is 10. And then we have 2 times 2 times 3 times 3. That's 4 times 9, or 36. 36 times 7, which is going to be a very large number here, 252. So as you can see, our 252 minus the 10 is not going to generate a 166. We have two groupings that are a little bit too unbalanced. So this is important to see because at this point we notice that we're going to need something a little bit larger than 10. This number needs to increase, and this number needs to, this one over here needs to decrease in order for us to get to 166. However, how can we change the 2 times the 5? There are only a couple of ways we can do that. We can add in an extra 3, or we can add in an extra 2 into our grouping. But let's see what happens if we test one of those. And I want to illustrate how that makes things a little bit crazy. For example, let's just take, let's see here. Let's take the 5 and the 2, and we'll group another 2 in with them. When we do that, and we take the rest of these terms, now all we did is we took the smallest possible number and added it into that group. Now I have 20 for my 5 times 2 times 2. And for the 6 times 3 is 18 times 7. And 18 times 7 is only 126. Well, that's not very good because when I subtract the 20, now my numbers are less than 166. In other words, now this number has to get bigger and this number has to get smaller. And so I look at that and I say, well, wait a minute. I just added the smallest possible number that I could to this side, and I was unsuccessful. So I have to change my thinking a little bit. I have to say, wait a minute, what if instead of making the 126 bigger and the 20 smaller, what if I make the 20 bigger and the 126 smaller? In other words, I don't want to make it so small that it gets to be less than 10, but I want to make it so that it's smaller than 20. So that's where my main clue comes up in this problem. So I look at the problem and I say, okay, how can I make this so that I can generate a number between 10 and 20 in one of the groupings? And right away, it pops right out at me right here. I get that 7 times 2. Now, there is another way to do it, and that's with the 5 times the 3, but that breaks the rule that we had back here where it's got to be even, even. So 7 times 2 is my only possibility. And then I'm going to group the rest of these here and see what happens. This becomes a 14, and then we have 15 times 12, which is 180. So 180 minus, oh gosh, I just wrote 16 there. That was silly. 14. And that gives me 166. So I'm able to get my middle term through that process. Okay, that was a lot to grab onto, but let's go ahead and work the rest of this out. Notice that the 24 was broken into the 2, 2, and the 3 are all together. That makes 12x, and then the other part is a 2x. And I will group the 2x with the 7, and then the other part is going to be with the 15. And finally, I'm going to need to do my signs here. This will be a positive, and the other one will be a negative in order to attain a positive middle term for 166. And there's the factorization of that monster trinomial.